Welcome to the lesson Relating Multiplication and Division for Problem Solving. This is lesson 1.8 through 1.9. Our goal is to solve problems that contain, or we could say problems having, multiplication and division, and we're going to use models to do that. There are some key vocabulary words that you need to understand in order to understand where you are on the scale. If you've forgotten what any of these words mean, you can check your vocabulary list, but you can also check the back of your Go Math book or use Think Central. It's important that you know what these words mean so that you can understand the scale. If you're not sure, pause the video and look up those words now. Remember this from 4th grade, the word fact family? Well, a fact family is made up of inverse operations. And here we have a nice little fact family. Inverse operations means opposite. So when we say that we have a fact family is a group or a family of facts that are made up of opposite operations. But instead of calling them opposite operations, we call them inverse operations. You probably remember this from 1st grade, 2nd grade as well. 1 plus 2 equals 3, and we know that 2 plus 1 equals 3, 3 minus 1 equals 2, and 3 minus 2 equals 1. And then we would say, oh, look, we have a fact family. Well, the same is still true, except we're using multiplication and division. So what should you get out of that? The opposite of multiplication is division, just like the opposite of division is multiplication. These are inverse operations. And then the opposite of addition is subtraction, and the opposite of subtraction is addition. These are inverse operations. We're going to use inverse operations when we model multiplication. And we're actually modeling multiplication and division because we can use inverse operations to check our answers. So if I had a problem that had 3 times 4 equals 12, I could check my answer with 12 divided by 3 equals 4. And if it was correct, then I know my answer is right. We're going to use that idea of inverse operations to check our answers when we use different models here. There are 3 different models for multiplication: the area model, the set model, and the linear model. Here you can see I've solved each of the problems using the models that are best. For example, in the first one about Ocean and her drawing 5 rows with 7 days in each row, that's 5 times 7 equals 35. And I used an array or an area model to do that. You'll see that first I numbered 5 rows and then I put 7 in each row, and that gives a total of 35. And so I wrote there are 35 days in all on her calendar, and I can check my answer using an inverse operation. Is 35 divided by 5 7? Yes, it is. I also can do a set model for this type of problem. We see that Owen has 3 snack bags and each bag has 21 snacks. Well, that's a set of objects. It's not an area model, like there aren't rows and a number in each row. It's a set model, like a set of pencils, a set of cookies, a set of plates, a set of toys, a set of candy, a set of trucks. So you can see we have the set model here. There are 3 bags with 21 in each bag. So I set up my problem. 21 times 3 equals 63. And I use the standard algorithm by doing 3 times 1 is 3, and then 3 times 2 is 6. And we get the number 63. There are 63 snacks in all. And the last model is what we call a linear model. Notice the word line in linear. Marika ran 2 miles a day for 7 days. How many miles did Marika run in all? Well, she ran 2 miles a day, so there's 2 miles in each group. And how many days did she run? 7. 1, 2, 3, 4, 5, 6, 7. So we jumped 2 spaces. How many times? 7 times. So when you run 2 times 7, in all. And we can use inverse operations to check our answer. Is 63 divided by 21 7? Or 3? Not 7. Is it 3? Yes, it is. Is 14 divided by 2 7? Go back and count our spaces, and we would find that 14 divided into groups of 2 actually is 7. Let's apply that same idea. Before, this was kind of a review, we did the 3 models, area, set, and linear. That's from 3rd grade. But now, in 4th and 5th grade, we are able to use the array, which is a type of area model, but we can also use the box model. I'll show you how that works. Some teachers wanted to plant carrots in the CCA garden. They decided to let each of their students plant 3 carrot plants. If 63 plants were planted in all, how many students participated in the activity? Well, there's a total of 63 plants in all. So in the box, I'll put 63. But let's see if we can set up this problem. 63 divided by 3 carrot plants, because each student has 3, and we're trying to figure out how many students participated in the activity. 63 divided by 3. I'm going to use what I've learned about the distributive property to break apart or separate the 63 into 60 and 3. So the total box is 63, but when I break it apart, I get 60 and 3. And what am I dividing by? I'm dividing by the number 3, so I'll put that over here. Now I'm trying to figure out 3 times what equals 60? 3 times what equals 6? Oh, 2. So if 3 times 2 equals 6, then 3 times 20 equals 60. There's a pattern there. Now I'm trying to figure out 3 times something equals 3. I know that one because that's the identity property. 3 times 1 equals 3. Now I can add up these two numbers. 20 and 1 equals 21. What is 63 divided by 3? It is 21. There are 20. There are 21 students. Is that confusing? You can definitely watch this again. If I were using the array, I have 3 plants per student, and I would just keep counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I would keep going until I got to 63, and that would give me a row of 21. So there would be 3 rows of 21. So that would still give me 63 divided by 3 equals 21. Here's another one. Some CCA students went to the Orlando City soccer game. They sat in rows of 5. If 115 CCA students went to the game, how many rows did they use? You can pause the video and try it on your own, or we can do it together. Well, what's our total? 115, correct? And we know that there are 5 rows. And we have 5 rows here. And we have a total of 115. So that means there are 115 students divided into 5 rows, the equal number of students in each row. Well, I can easily see how to distribute 115. I will break it into 115 because I know these numbers will be easily divided by 5. Here's 115. 5 times what equals 100? Well, I know that 5 times 2 is 10, so 5 times 20 must be 100. 5 times what equals 15? Oh, I know this fact. 5 times 3 equals 15. So 20 plus 3 equals 23. 115 divided by 5 is 23. There are 23 students in each row. Uh-oh, there's an error alert. Did you notice the error in the problem we were doing together? The question says they sat in rows of 5. If they sat in rows of 5, that means that there are 5 students in each row, and we're trying to figure out how many rows there are. So what we should have in our array is 1, 2, 3, 4, 5 students in each row like this, and then there should be, going down, there should be 23 rows. So it should be 5 students and 23 rows. 115 is the total. 5 is the number of students. And 23 is the number of rows. This is the incorrect array for that model. Good job if you caught that. And now it's time for you to try a multi-step problem on your own. Pause the video and see if you can solve this problem on your own. Here is another problem. Pause the video and see if you can solve this problem on your own as well. Then come back for the answers. Here's the moment you've been waiting for. Use this information to check your answers. You can pause the video to check your answers for this problem. And you can also pause the video to check your answers for this problem. Remember, if you have any questions, write them in the Ask Questions section of your square and ask your teacher tomorrow. Locate where you are for today and be sure to let your teacher know any questions you have or what you did not understand when you meet with her in the next session. Thanks for watching.